Thank you very much for the invitation. It's very nice to be here and to share our experience, in this case regarding to critical infrastructure, schools, mostly schools that we, for damage done related during after the earthquake of November 2009. I will focus quickly on 4 topics: education facility buildings prior to the earthquake, so their situation, the earthquake of September and November, because I need to point something about damages came to Albania previous to earthquake of 26 November, safety behavioral damages happened of education facilities, and some new ongoing analysis and conclusion remarks. Regarding to the typology of the buildings, of education facility buildings, those are some distribution of typology. So we have around 25% of buildings previous to 60 constructed, 50% of them up between 60 and 90, and after 90, almost 25%. So, but regarding to main material, that is the number that in Albanian scale we have 65%, 75%, sorry, masonry and 25% concrete. Most of concrete are after 90, the percentages. And some others, most of them are 1 to 2-story buildings, and only 15% are 3 to 5, to 3 to 4. Because our codes doesn't allow more than masonry buildings more than 4-story for educational system, we don't have too much. Only 0.5% are masonry with more than 4 stories. And some percentages regarding the kindergarten, elementary school, and high schools distributed around Albania. I selected those buildings. The first one is reinforced concrete placed in doors, but fortunately without too much damages, even it is a flexible structural system. And the second one is masonry, but both of them constructed mainly previous to 90, but even after the shape remained regular in most of the education facility buildings nowadays. And both of buildings react good for both earthquakes, September and November. We didn't get too much damage. The second one has some slight damages that I'm going to show maybe some of them. And regarding to our codes, there are a lot of criteria regarding to masonry buildings, especially for schools and special buildings, let's say, in order to improve their capacity against the earthquake. So, regarding the height of the building, transversal wall spacing, distance of the, let's say, wall in the corner, ratio between the length and the width of the building, as well as opening, windows opening, because these are two most typical school buildings, masonry, with masonry structure. Symmetrical and asymmetrical is a name that they put it for architectural purposes, not for the structure. Like structure, both of them are main regular structure. The main issue that we found even after the earthquake is the distance of the transversal wall on those buildings. Some of them, even some weakness that they have intervened into those buildings, but the main issue is this: in some classrooms they need larger spaces and they have transversal walls more than 10 meters in some cases. So that is the one of the weakness points that we have. This is one of the buildings that I showed at the beginning, that all of, mostly the education facility buildings remain almost with regular and with following criteria that they have been imposed. Standard elements, regular, open, narrow, not on big windows, let's say. Maybe that is, from architectural point of view, it is not so good, but those are like regular with low width. And some of the damages that have been focused after the earthquake is that in those masonry structures that they increase the opening of the window, we have saw a lot of damages in the cracking area. This is a photo of the same building, because this building now it is demolished, but this is the photo after the earthquake. This is because in 2008, I don't remember exactly, but it is reconstructed, and they have not structurally, but they have increased quality of the school. Something regarding both earthquakes, I need to emphasize, because there are some elements that we can derive from what we registered during the earthquake. Unfortunately, we don't have November earthquake full registration, only 15 seconds. But we strongly believe that we have the big ground acceleration value. Maybe for the higher period, larger period, maybe the spectrum will be higher, but that is a problem, and we cannot go farther. Some investigation maybe need to be done. But you can see with the red line, there are earthquakes in Tirana, registered in Tirana, and the black one in Durs, both of them with dash lines. Both of the earthquakes are from September, 9 September, and for short periods, even September has such a strong acceleration on some steep buildings. So even schools, and we have some documentation of that, have cracks during September. But as there is no fatalities that time, everything it has been gone. That after, let's say, 10 or 15 days, everything as it's turned to normal. But when the November earthquake comes, maybe a lot of other issues that was hidden during September appear again. The most important thing is that the registration indoors, it is a category of soil, not D, but it is S, because now we have even some proof that we have lower velocity, shear wave velocity in the, not in the surface, but in between 15 to 25 meters. So we have lower velocity than in the upper layer of the surface. So even from the specialists, they believe that all that area, much more affected with flexible structure, is S1, or the side effects there has been higher. We cannot measure it, but more precisely because only that 50 seconds of earthquake we know exactly. This is both epicenters on both sides. Fortunately, for both main cities, Tirana and Durs, during 85, at that time, they have prepared seismic microresonation maps, so more detailed information has been used for the design of buildings. And that, from my point of view, is one of the reasons that, of course, there are a lot of damages, but not too many collapses during the earthquake in the area where the seismic force has been really high. Regarding some calculation from seismic behavior of buildings, we saw and found that mostly the buildings, critical facilities like schools, suffer not too much damages. but anyway, there are some of them. For example, if this is a study previous to an earthquake, and using the data and comparing the results with after those, this is masonry typified building, and this one is another frame system, and both of those buildings with the earthquakes shows that only few slight damage will happen. So comparing with the results taken from the after the earthquake on those buildings, there are no damages on both of the buildings in order to consider medium or high damages. But from the other side, there are some buildings that suffer too much damage. This is in another area with soft soil condition in Tirana, and the two-story buildings, school buildings, is heavy damaged. But the problem is that even if it is damaged from the earthquake, you can see here the spandrel is totally crushed, but the problem belongs earlier, because in the building they have found damages even after the earthquake of 4 July 2008, and didn't took any measures regarding structural safety. They put in the building, because the photo is done at the end of the process of making reconstruction, but reconstruction without any structural improvement. And the damage has been there even previous to earthquake, previous to in 2018, 2019, September, and after that earthquakes on November, 26th November. And the second one is a new building, and that is a problem because fortunately it is the most damaged building in Albania during the earthquake, but highly damaged because reinforced concrete. There are a lot of other reinforced concrete there with light damages, but this one is really damaged, and it is constructed 2010. The problem with that building is that exist different elements, number of stories that maybe at the beginning it was planned for 3 stories and it finished with 4, but even some details regarding stirrups in critical areas. Preparing some simulation model, even from the model you can see that the capacity, putting there some spectra correcting the acceleration, so with the same earthquake that happened, the capacity is the end. Irregularity in plan irregularity and construction details lead to some damages in the upper part of the columns. In our tradition, we put stirrups much more in the bottom part when the overlapping of the reinforcement take place, but not in the upper part. So that is one that comes from old code in use, not from old code. I'm talking about 78, because if you want to take 89, we have strict condition for those joints. And this is some, in general scale, regarding the damage, because after the earthquake, different reports collecting data for the damages in Albania are prepared. Regarding to any columns, you can see here I selected only education facility, and the first one is the first collecting data from the Ministry of Education. And there have been 56 heavy damage building, 66 moderate, and 151 light. Another one, it is a World Bank document, even the document is published, that in the moderate damage building is less in number. PDNA document, and the last one is some simulation that we have prepared in order to check it to see what, to simulate the same earthquake, what will be the damages in that area. And of course there are some increasement to the light damage, but we believe that maybe the number has been even more to the light damage. Not every light damage is to be declared. So a comparison between what we gathered by the field investigation as well as by some simulation of damage during after the earthquake. And the last one are two maps. Roberto mentioned previously that in Albania we have two draft maps for seismic hazard, two different studies, and even now it is not, we don't have a final version. So the first one is seismic map, a proposal from IGEO, and the other one is from Academy of Science, 10 years previously, but we need to have some estimation, and here we have two different preliminary studies, let's say, regarding seismic risk assessment. In the second map, it is exposure model that we build about the information that we have till now. The third one, regarding the vulnerability, mainly focused on in schools we have fragility curves, but even for other buildings we need to follow the code in order to have general fragility curves, not in more detail. But in the case of school, capacity, vulnerability or fragility curves are derived directly from the model. And the last one is the risk data that in both cases that we can use each of the map. Tirana remained the main city with high risk regarding the seismicity. So, regarding the conclusions, I'm focused only on some of them, mainly for the masonry facility buildings. Diagonal cracks in masonry walls and damage near to window door openings have been present in several damaged facility buildings. In some cases, also non-proper design and construction detail increased damages, like the reinforced concrete building. Light cracking on masonry walls, plaster, parapets, and other non-structural are widely spread in the educational facility. Even the deterioration of the material and lack of maintenance has been proven that has been part of adding some damages. But the main reason is the damage that can be attributed also to intervention throughout the years. For example, adding of stalls, extension of floor areas, wall removal, and openings, without due considering about the effect of safety. So they are going to make intervention, but not considering the structural capacity. And some recommendations that we think that maybe are on the top, but exist. There are a lot of others. Intervention to existing education facility requires to pay higher attention to seismic safety. Throughout the years, the intervention have been done focused much more on service improvements. It is important to have an up-to-date detailed database of the existing education facility, and the program for continuing monitoring, as well as for studies for seismic vulnerability and risk of schools, is recommended. One of the main things is that a lot of, I can say even 50% of the education facility in Albania are typified structures. So if you are going to pay attention to some of them, you are going to improve the capacity with a lot of. And the last one is related much more to some private schools and kindergartens. So we have schools designed and constructed properly for this kind of activities, but there are a lot of others that are going to have activities in buildings designed without proposed being schools. So even that point must be one of the important things to follow. The last one, I put this photo because I like the shape of the structure. So it's a pyramid, but regarding this is the same school that is collapsed, but it's much more architectural design. But thank you.
Thank you. Any questions? Markel, please.
I just want to ask you, because you already had quite, let's say, unfortunate cases where you renovate cosmetically at some schools, but then they get damaged to a different extent. And as I remember, at least one was demolished,
Yeah.
although it was looking good on the facade. So does this did this ring the bell in the government to include seismic strengthening when for future, or maybe future, it was in 2019, so for current projects already, when they try to renovate schools or kindergartens, do they also include at least seismic assessment, if not proper?
Till now I can say it no.
Okay.
I'm going to say it, but maybe some measure regarding to the procedure, how to assess and to retrofit, we have in paper, but going through some intervention.
So, but at least
I believe
some kind of evaluation is
I
already.
believe that the process damage, has been damaged by at the beginning by the pandemic, but now the government is pushing to have this seismic risk assessment and the panoramic view as a whole, and going to some much more details. But till now, I am afraid that the only sporadic or few cases has done relatively properly.
Thank you very much.